Hello, welcome back to our next geometry lesson. Again, I am taking you through some vocabulary, so I hope you're ready to write some stuff. Make sure to take the time to pause the video and get all that vocab written down so that you can see what you have and you can reference this later. It will be super important. Hopefully these first four words are things you know, because you probably learned it in like elementary school, if we're being honest here. An acute angle is an angle whose measure is, I should go on the next row, it won't fit there. Measure is less than, what number is that all? It is 90 degrees. So any angle that's less than 90 degrees, and it's an acute angle, it's a acute angle, so it's gonna be little, it's gonna be little and cute. There we go, there's my little acute angle. You can see that it's less than 90. It is a small little angle that has just a small opening over here that's less than 90 degrees. Next one is going to be the obtuse angle, which is an angle whose measure is between 90 degrees and 180 degrees. So this is going to be an angle that's a little bit bigger, and maybe it's going to have an opening that looks like that. Notice that the opening goes past the 90 degree mark, which we haven't quite talked about, but again, I'm sure you know the 90 degree mark is when we go straight up. So the opening is further than that 90 degree corner. Which brings us to our right angle. A right angle is an angle whose measure is equal to 90 degrees. It can't be anything less than or anything more than 90. It's exactly 90. And when that happens, we have an angle that looks like this. And this is really important. When we do angles that look like this, we're going to put a little box here. That box represents a right angle. So if you see in any sort of diagram a box like that, then you know that that angle has to be 90 degrees. It's a right angle. That's going to be really important because as we start doing proofs going forward, which is going to be what the next two topics talk about, you're going to need to pull stuff. You're going to need to pull givens from diagrams. This is a given. It tells you, hey, this angle is 90 degrees. So that could be super useful to us. And the last one is an angle, a straight angle. It's an angle whose measure is exactly 180 degrees. And that's gonna look like this. Boop, boop, boop. So it's just a little, a vertex. It goes straight out in both ways. It's perfectly straight, kind of like, I mean, it is a line. It's essentially a line, but we also know it's considered a straight angle. I'm gonna put that there just to represent that we are talking about an angle. So before I go on, there's a few other important things here that would be important for us to know going forward. For example, this part right here has a specific name. We call that the vertex of the angle. And every angle has one. Here's the vertex here, here's the vertex here, and here's the vertex here. So that's gonna be super important to recognize. Notice that an angle is also composed of two pieces, right? If I start at this vertex and go straight up, we recognize that this is a ray. Additionally, if you start at this vertex and go this way, that's another ray. So an angle itself is just two rays that are sharing an endpoint known as the vertex of the angle. Which brings us to the straight angle. You can see that this represents what we would call opposite rays, right? I have a ray that goes one way, a ray that goes the exact opposite way. So this would also be considered opposite rays. So not only is it a line and a straight angle, it's also a pair of opposite rays. Another thing to talk about when we're discussing angles is how to name an angle. And that can get a little bit confusing at first, but once you get the hang of it, it's not too bad. For example, if I put some letters here, let's call this angle L. We'll put an A here, and we'll put a B there, angle lab. When I go to name this, the vertex always has to be the second letter. And then I can name it in any direction I want to. I can go angle L, A, B if I want to. So I'll put angle L, A, B. Notice the vertex is directly in the middle of the three letters. I could also go backwards. I can go B, A, L. So I could call this angle B, A, L. Notice again, the A is still in the middle because that's the vertex. B and L can go wherever they want, but A has to stay in the middle of that. And the only other thing you may see is notation like this. Let's call this angle X, Y, Z. They may put something like this. M, angle X, Y, Z is equal to 90 degrees. This reads as the measure of angle X, Y, Z is equal to 90 degrees. So if you see that little M in front, it's just them telling you how many degrees that angle is, the measure of the angle is. So that can help us as we move forward as well. All right, coming down here to some additional vocabulary. Complementary angles. I'm gonna write the word comp right here. Complementary angles. What that means is two angles whose sum, meaning if I add them together, is 90 degrees. So if I take two angles and add them together, I'm going to get 90 degrees for their sum. I wrote the word comp here because watch what happens. If I put a little dotted line right here, notice that this is the number 90 now. So if you ever forget a complementary is 90, or you'll see in a second why you might get it mixed up with supplementary. If we put a little line there, you can see there's a 90, so it tells you, oh yeah, complementary needs to add up to 90. So I'm gonna draw a picture over here. Let's put an angle right here, and then over here we'll put another angle. Well, it's kind of hard to tell right here, but if I put some numbers here, maybe this angle's 80 degrees, and maybe this angle's 10 degrees. Well, if I combine those two together, 80 degrees plus 10 degrees would give me 90 degrees. So that would mean that is a pair of complementary angles, because when I add their angle measures together, I get 90. Supplementary is gonna be kind of similar. I'm gonna write the word sup there again. So supplementary is two angles whose sum is 180 degrees. So if I put them together, they make a straight angle or a straight line at the bottom. Again, if you look at this word sup, if I put a dotted line here, then I can just put a 1 and a 0 on the other side. You can see it makes an 8. So when I put that 1 and that 0 on the other side, I got 180. So you remember supplementary becomes 180 because if I put a line through the S, I get an 8. Make sure you don't mix those two up. They're the most common mixed up thing. The other way you can remember too is complementary comes first alphabetically before supplementary, meaning 90 comes before 180. So complementary and 90 both come first, so they go together. Supplementary and 180 come second, so they go together. And if I draw my picture over here, we're gonna draw an obtuse angle. Let's say this one is 150 degrees, and I have this little acute angle here. Well, this acute angle has to be 30 degrees. And if I add 150 and 30 together, I get 180 degrees. So I know this would be a pair of supplementary angles. My next two, a pair of vertical angles. Well, vertical angles are going to be two angles formed by the same two lines that are opposite of each other. Opposite to each other. I'm running out of space. So two angles formed by the same two lines that appear to be opposite of each other. So what that means is I'm going to draw a line right here, and I'm going to draw another line right here. And so my vertical angles would be, for example, this angle right here and this one right here. Notice how those two angles are opposite of each other. So I can call this maybe angle A, and this one also angle A. Those two angles are going to be vertical. This also has a second pair of vertical angles right here. I'll put 2 marks right here and 2 marks here, right? Those two are opposite of each other, so those are also going to be a pair of vertical angles. So I've got 2 pairs right there of vertical angles. And we're going to talk a lot more about that as we move forward. This is going to be a really important vocab word that will follow us through this year, so make sure you're okay with that one. And the last one we have to copy down is a linear pair. A linear pair is 2 adjacent. Maybe we don't remember what adjacent means, right? Adjacent means next to. Like this box is adjacent to this box. This box is adjacent to this box. This box is adjacent here, right? Anything that's next to each other, that would be considered adjacent, right by each other. So 2 adjacent angles that are also supplementary. So it's 2 adjacent angles. That's not how you spell it. Yep, no it is. Mentary. I teach math, not writing. Supplementary, there we go. So that would look something like this. Up here you saw the supplementary angles were just two angles that added up to 180, right? But for it to be a linear pair, we can use those same angles, but notice this time when I put them in, this is my 150, and this is my 30. Notice that those two angles are adjacent to each other when they add up to make 180. They are sharing one of their sides, one of their rays is being shared amongst the two of them. So linear pairs have to be adjacent to each other, while supplementary can have a space between them. So they're very similar definitions. Just keep track that this was what separates them from each other, is the adjacent part. So let's take a look at these practice problems that we have for this. All right, so example 1 says, find the missing measures in each figure. Keep the angle relationships in mind. So if I look here, I can see that this is a pair of complementary angles because I see that they have a 90-degree box right here. So these two angles have to add up to 90. So I have 68 and x add up to make 90. I'm gonna write that out as an algebraic formula at first. So x plus 68 equals 90. Well, if I saw the algebra here, we would know that I just need to subtract 68 from both sides, and that would tell me what x equals, right? So if I subtract 68 from 90, I'm gonna end up with 22. So I know that x has to equal 22 degrees, and we could easily go back and check our work. What is 22 plus 68? Well, if I add 2 onto 68, I get 70. 70 plus that additional 20 does give us 90, so that does in fact work. Take a look over here, we can see this would be a linear pair of angles, right? This one here forms a linear pair. So I've got this 124 and this linear pair x. So I know they're gonna add up to make 180. So x plus 124 equals 180. And again, we subtract that 124 from both sides to get x by itself. And I get that x is equal to 56 degrees. And coming over to this last one, ooh, this is a little bit crazy, right? We got 3 variables going on here. So let's start by looking at, let's just go in order, x, y, z, right? If we look at x, well, x and 43, don't those form a linear pair with each other? Those two form a linear pair that adds up to 180. So I know that x plus 43 equals 180. I'll subtract that 43. That's gonna give me x is equal to 137. So I've got 137 degrees here. Well, now I know that x and y form a linear pair. But if I set up this equation, right? I mean, let's look at it. Y plus 137. Y plus 137 equals 180. And so I could subtract 137 from both sides. But if I do that, well, then I'm going to get y equals 43, right? That makes sense because we already determined that these two values are supplementary values to each other. So then this has to go here so that these also form a supplementary pair, right? If you add 43 under the 137, we'll get 180 again. And taking a look down here, we got this last one. If I have 43 as angle y and I want to find z, well, those again are supplementary because they make a straight line. Well, we know that 43 can only add to 137 to give us that supplementary pair. So ultimately we know that z and x are 137 degrees, y is going to be 43 degrees. Next, we're going to talk about example 2. Angle A and angle B are complementary angles. If the measure of angle A is 42 degrees, find the measure of angle B. Hopefully you're starting to see the pattern. If I have a pair of complementary angles, well, all I have to do is take the value 90 and subtract the one we know to get the one we're missing. So if I take 90 and subtract 42 from it, we're going to end up with 48 degrees. So I know that the measure of angle B is equal to 48 degrees because 48 and 42 will add up to make 90. Angle P and angle Q are supplementary angles. If the measure of angle Q is 64 degrees, then what is the measure of P? Well, again, we know supplementary means 180, and so we'll just do what we've been doing. Take 180, subtract what we know, which is 64, and that will give us whatever's left over. So I take 180, subtract my 64, and I get 116 degrees. So let's write that out. The measure of angle P is equal to 116 degrees. And as always, we could go back and double check our work, add those two together and make sure we get 180, and we do. In example 4, it says angle 1 and angle 2 form a linear pair with each other. If the measure of angle 1 is 113, find the measure of angle 2. These two problems are almost identical. Like, we know that supplementary pairs don't have to be adjacent, while linear pairs do, but that doesn't affect this problem in any way. Finding the other pair is still going to function the exact same way. Linear pairs add up to make 180. let's subtract the one that we already know to figure out what's left over. And so if I do that, I'm going to end up with 67. So the measure of angle 2 is equal to 67 degrees. Example 5 says if the measure of angle PQT is 3x plus 5, and the measure of angle SQP is 2x minus 25, find the measure of SQR. Well, let's go ahead and plug some things in here because I think that's going to make our life a little bit easier. Angle PQT. Notice how I'm following the letters. PQT, PQT. Well, Q is the vertex. I'm going out towards P and out towards T. Looks like it's going to be this angle space right here. PQT, because that's what's inside. So I'm going to put my 3x plus 5 there. And then SQP, SQP, again, Q is still the vertex. So it looks like this part is going to be the 2x minus 25 towards P and towards S. Well, if you look at those two things, what do we know? Are they a complementary pair of angles, a supplementary pair of angles, or a linear pair of angles? Well, this is going to be a linear pair, right? They share a side and they make a straight line to 180. So I'm going to add those two things together. Well, I know that if I add those two things together, it'll equal 180, right? So if I add this angle and this angle, I should get 180 degrees. Well, we don't have angles there, so we're going to have to add equations together. So I'm going to set this up in a vertical fashion. So here's 3x plus 5. We'll put 2x minus 25 underneath it. And now let's add these things together. 3x plus 2x is 5x. 5 and negative 25 is negative 20. So when I add those two equations, I get 5x minus 20. And we can set that equal to 180 degrees. We're going to have to solve that to figure out what x equals. So I'm going to draw a line right down there so I can keep track of where my equal sign is. We'll add 20 to both sides. So I end up with 5x left on the left side. And 180 plus 20 is going to be 200. So I'll go ahead now and divide by 5. And I end up with x equals 40. Well, if you stop right there, you are not going to get this question correct. It says find the measure of angle SQR. SQR, well, that's this angle down here, which I don't even have an equation for. Well, that kind of runs us into a small problem, but we can figure that problem out. Take a look at problem C that we did up here, right? We recognize that when I did this, that if this angle and this angle are supplementary and form a linear pair, well, then these two also have to form a linear pair, which means they're supplementary, which means these two form a linear pair. So you can kind of see what pattern happened. And we're going to get into proving this and talking about this later in the next couple videos. But you can see that these values come out to be the same thing. The opposite vertical angles are going to be the same thing to each other. So we know that whatever SQR is going to be the same thing as 3x plus 5. So I'm going to take the value of x, which is 40, and plug it in for 3x plus 5. So 3 times 40 plus 5. So 3 times 40 is going to give me 120. And when I add 5, I get 125. So this is 125 degrees. And so that means if the 3x plus 5 is 125 degrees, PQT is 125 degrees. That would have to mean that SQR is also 125 degrees. So maybe we should actually write that out. The measure of angle SQR is equal to 125 degrees. And rounding us off with this last example, if angle DCB forms a right angle, and the measure of angle DCE is 7x plus 2, and the measure of angle ECB is x plus 8. Find the measure of angle DCE. Well, they told us that DCB forms a right angle. You can see DCB. So this angle right here has to be a 90-degree right angle. They told me that the measure of angle DCE is 7x plus 2. So DCE, well, you can see that's like this top half right here, right? D to C to E is this opening right here. So this is going to be 7x plus 2. And the measure of angle ECB, which is this little guy right here at the bottom, is going to be x plus 8. So I can get those two pieces in there, and we know they're complementary to each other because they form a right angle. So I know if I add these together, I should get 90 degrees. So let's do that. 7x plus 2. And underneath it, I'm going to get x plus 8. My x's are lined up. My numbers are lined up. And let's add that. 7x plus x is 8x. 2 plus 8 is positive 10. So I have 8x plus 10. Set that equal to 90 degrees since it is a right angle. And we'll work through this. Subtract 10 Subtract 10, those cancel, and I get 80. And that leaves me with just an 8x over here. So now I just have 8x equals 80. So we'll divide by 8. That leaves me with just an x, and 80 divided by 8 is 10. Again, double check. What did the question ask? Anytime I get x equals in geometry, always pause and say to yourself, do I need to go back and plug that in? Because it will be the biggest reason people get questions wrong on tests. Find the measure of angle DCE. They didn't want x. They don't care about x right now. They want the measure of angle DCE. Well, DCE is this 7x plus 2. 7x plus 2. So I'm going to plug in that 10. So 7 times 10 plus 2. 7 times 10 gives us 70. And 70 plus 2 is 72 degrees. So the measure of angle DCE is equal to 72 degrees. And that is our final answer for the final question. If you have any questions, as always, make sure you make some notes of those, bring them in, let's talk about it. And as always, have a wonderful day.